AI today is powered by advanced hardware, and sustainable AI adoption requires us to look beyond today's solutions and to anticipate tomorrow's challenges. So our next speaker will share with us and go beyond GPU to introduce the next generation of AI technology and infrastructure needs, what we need for the future of AI today. So ladies and gentlemen, let's put our hands together and welcome Scott Albin, General Manager at APAC Groq, to share with us more. Over to you, Scott.
Testing. Okay, I think it's working. All right, hi everyone. All right, I'm going to talk to you a bit about Groq. I'm also going to talk to you about what it's going to take to build and service the AI economy in Malaysia. I'll tell you a story about Groq because you might not know the business. Groq was founded by an individual named Jonathan Ross. Jonathan was at Google about 10 years ago, and he invented a chip called the TPU. So if anyone knows anything about Google, they have their own proprietary chip that they use for AI all over the world. It's called the TPU. So Jonathan invented that. It was a side project, a 20% side project of his. And he worked on that for a number of years at Google, but he got frustrated. And he left. And the reason he got frustrated was he saw all the amazing AI that was happening inside of Google, but he looked outside of Google, and no one really had access to that technology. He also looked at the cost to actually service the AI inside of Google, and it was extraordinarily high. Now, the TPU made it cheaper, but the actual cost structure was enormous. Now, Google could afford that, but Jonathan recognized that if you wanted to actually give AI to everyone in the world, it had to be much faster, it had to be much cheaper. And so he left, and he created this company called Groq. So, Groq is headquartered in the US, in Palo Alto. We produce a chip that I'll talk to you about called the LPU, and we build this whole system around it. It involves networking, technology, software, and tooling that helps developers run AI models, all the popular ones that you know the names of, all over the world, but we do it faster, and we do it cheaper, and we do it more energy efficient than anyone else in the world. So here's what these systems actually look like. We have our Groq chip, the LPU. This chip is quite extraordinary. It's one of a kind in the world. It's the largest single core chip ever created. It's a 14 nanometer chip, the one that you see pictured here. So it's quite old fabrication technology, but it outperforms GPUs. And I'll show you a couple examples of this. We're making more advanced chips also. These chips are getting produced at a cadence of almost a new generation every single year. And these chips are unique in their supply chain. We do not use Taiwan or TSMC. All of our chips are actually made in the US. We're the only company in the world who makes advanced chips for AI in the US. Pretty relevant in today's political climate. Now, these chips go into systems. These systems go into data centers, and that powers the Groq Cloud, which I'm going to talk to you more about. The Groq Cloud is quite an amazing bit of technology that developers around the world, including here in Malaysia, tens of thousands of developers here in Malaysia, have signed up to use. So I think seeing is believing, so I have a couple demos for you. So let me show you that now. Oh, sorry, just before we get there, everyone wants to know the performance difference between our chips and GPUs. So look at these numbers on the screen. 3 different ways to compare the Groq systems to GPUs. The first, time to completion. Time to completion is how fast you get that response back from the AI model. You type in a prompt, you get a response back. It takes a while to complete. That's the time to completion. It's about 5 times faster. And then that response you get is made up of tokens. Tokens are like individual words. These tokens have a cost. Our cost structure is about 1/10 of a GPU. And it takes energy to actually produce these tokens also. Now, our system is so energy efficient, we actually use about 1/5 of the power required versus a GPU-based system. So that allows us to deliver AI at a faster speed and at a lower cost, which is Jonathan's vision. He wants to drive the cost of AI to 0. Okay, so now let's do the demos. Let me show you what this looks like. So here is a comparison of the Groq system. You see that on the left in the orange, compared to GPU-based systems. Now, we're using a model, the same model, across the all three examples. This is a Llama 4 Maverick model, open source model. So here we go. So it's going to put a prompt in, tell me a long story about the first manned mission to Mars. So there you go. You see the Groq output happens extremely fast. This is not sped up. This is not manipulated in any way. You can go to groq.com and on your phone even, and you can type the same prompt in. You'll see the exact same result. It's just simply much faster, over 5 times faster than the GPU-based systems. Now, I think this side-by-side is interesting, but I think put it in a consumer point of view. They're using ChatGPT, they're using Perplexity, they're using these consumer-facing apps. I think probably most people in here have used those, and you probably have used deep research, either from OpenAI or from Perplexity or from Google. So let's look at an example of deep research built on Groq. Now, if you're familiar with deep research, you know that the whole idea is that you give it a prompt, and then it tells you to come back later. It says, close the browser, come back later, go get a coffee. So let's look at a deep research example built on Groq. So I'm putting a prompt in there. It says, I'm at the ASEAN AI Summit in Malaysia. Give me a detailed report on the AI economy in Southeast Asia. So here we go. We're going to start that research. It's going to use a couple different systems, a couple different models that we host on our Groq Cloud. It generated the research plan in 0.3 seconds. It did the research in 3.8 seconds, and it finished the report. It's done. So it went through, it scanned 35 different websites in 3 seconds, and then it produced a report. Very similar to the type of deep research reports that you would see from any of the other familiar brands. Now, this is just a lab example that we put together for demo purposes, but it illustrates what the speed difference means in the hands of a consumer or a business user. A long time ago, Google won the search game, and they won that initially because of speed. They learned that if you take out the time people wait for a response, every 100 milliseconds, you decrease the wait time for the customer, their engagement level goes up 10 or 15%. And what we're demonstrating here is the same thing with AI. The faster you can make it, the more engaging it is, and the more people will use it. Now, of course, it also has to be cheap, because nobody wants to pay a huge fee for these services either. All right, so all that is powered by Groq Cloud. This is the full stack technology that we have been building over the last 8 years. It starts with the chips, the LPUs, and then we build up from there, the systems, the networking, the runtime systems, the compiler, all of the orchestration layer. And all this is available now to developers around the world through APIs. So you don't need to know anything about the hardware. And it's been pretty successful. We launched 16 months ago, and around March of 2024, and we just crossed 2 million developers who've signed up to use Groq Cloud. Over half of these developers are in Asia. A huge number of them are in Southeast Asia. And we're pretty happy about that. And that's with no marketing, with no real on-the-ground activity here. We've attracted, I think, those developers, really the groundswell of how powerful the technology is. And we see this popularity now of Groq reflected in the surveys and studies. So this is a survey from Artificial Analysis. If you can't see the numbers, what this is reporting is a survey of which inference providers are developers using to build their applications. And you can look on the left, and the demand is very high for OpenAI, for Google, Anthropic, Microsoft, but Groq is actually the next one. We are the 5th most popular inference provider. And we only launched 16 months ago. On the right, you can see a chart of the change from a year ago in terms of popularity. You see that OpenAI has increased in popularity, Anthropic has increased, Google has increased. Azure is actually flat. Amazon has actually gone down, and Groq has shot up. We think we'll overtake Azure very soon. But we still have a lot of building to do. We have to deploy a tremendous amount of infrastructure all over the world in order to support this customer demand. And just as a point of comparison, well, here's where we're planning to build. We're live in the US and Canada. We just went live in Europe. We're going to go live in Australia and Japan very soon. And then Southeast Asia is the one that we're here working on and trying to figure out the solution for. Perhaps we'll build in Malaysia. We're very actively evaluating that as an option. But we're trying to build the world's largest inference cloud. Today we have roughly half of the capacity of say, one of the hyperscalers in terms of inference capacity of our systems. And by end of next year, we expect we'll be the world's largest provider of inference, bigger than any of the hyperscalers. The reason we can catch up and shoot past them is because of the throughput of our system is so great, and the cost to produce it is so low. So let's talk about the AI opportunity in Southeast Asia. And I want to just start by saying, sharing a very basic statistic. You may have seen this research on the training versus inference demand around the world. Training is what so many people have focused on for so many years, but inference is actually running the models. I think most people in the room probably understand that. The inference demand is going to be the majority of compute around the world in AI. And we actually think of it like a utility. We think inference is going to be much more like electricity than it's going to be like a cloud service. And I'll explain that more in a little bit. But I just want you to keep that in mind. Inference is the majority of the compute in the world. And we see this is playing out now, actually. If you look at some of the hyperscalers, they've actually started to share the amount of tokens that they're generating around the world. So here's Azure. And this shows their Q1 2024 to Q1 2025 growth in token volumes. Quarterly tokens processed. They went from 20 trillion to 100 trillion tokens over the course of that year. Google has done even more. Now, Google has Google Search, and so these tokens reflect all of the Google searches and all the AI-powered search results. So they're shooting up even faster. They went from 10 trillion tokens in May of 2024 to 480 a year later, and in just a couple of months, they doubled that to nearly 1,000 trillion, or 1 quadrillion tokens. It's pretty extraordinary. So the growth is just parabolic. It's just going up and to the right. And we see the same at Groq with our systems. As we turn on more infrastructure, the demand just goes up and up and up. And so the opportunity for AI in Southeast Asia is significant. By some reports, it's 115 billion prize at stake. And now that's measured through a variety of different ways. Productivity is one of them. But this really impacts every sector of industries across Southeast Asia. And in Malaysia, it's very significant. I think it's expected to provide a 14% uplift in GDP by 2030. Pretty amazing if that actually happened. But there's a problem. The problem is there's not actually enough infrastructure to achieve this outcome. It's easy to say AI is impacting every organization. It's easy to talk about the use cases, and you've probably heard about many on this stage. But the reality is there's not actually enough physical infrastructure to power all of the tokens and generate all those tokens required to actually have that kind of uplift. Not currently. We actually had a quick look at some of the hyperscalers that operate in the region, and we asked a very simple question. Do they have the latest AI hardware here, the latest GPUs, is what everyone associates to? And the answer is no, they don't. Over 60% of the world's advanced AI infrastructure is in the US. China has a huge portion also. And the rest of the world is kind of waiting in line, including Europe, Asia, Latin America. NVIDIA only makes 5 million GPUs a year. Most of them are deployed in the US. Now, I'm not here to pick on these hyperscalers. I think that they want to deploy GPUs here. I'm sure they do. But there's just not enough of them to go around. And so the question is, how long will you have to wait in order to have access to the latest hardware, in order to achieve that $115 billion economic prize that's been estimated? I think there's a different way to think about this problem. And I think the countries are going to have to start thinking very differently about this problem if they're going to have unlock the supply chain and build the infrastructure that's required to achieve this outcome. And so I want to talk to you about how big this AI infrastructure needs to be. So we have a very simple system at Groq of estimating how many tokens do you need at a national level to power AI across major categories of applications. If you ever use ChatGPT or some of these other apps, you're generating tokens with every query. If you use it in a business setting, you're generating tokens with every prompt and every query. And you can actually estimate the number of tokens on an individual basis. Now, by some estimates today, the average tokens per second per individual, it varies around the world, but we think it could be anywhere from 0.2 tokens per second to 1 token per second. We use this estimate of 87 tokens per second. And maybe that's looking ahead a couple of years. Maybe that's a forward-looking estimate, but we think that's directionally where the market is headed as everyday individuals use AI more and more. And so what do you need to power the AI economy for Malaysia? Well, for 36 million people, it's about 4 trillion tokens per day. Per day. It's a lot of tokens. Now, how does that actually break down? Well, if you look at the major sectors where AI is going to have an impact, citizen-based services, public sector, enterprises, startups, research, you can break this down into individual categories. And if you look at the share of population, and you look at the typical token volumes that are required for these different categories, which we can benchmark to market based on what we see today, you can actually come up with this number. That's how we came up with the 4 trillion a day. The problem is, tokens today, if you look at the prices that are charged by many of the major inference providers, they're charging you over $1 in some cases per million tokens, a couple dollars. Anthropic charges $75 per million tokens for their Claude Opus model, $75 per million tokens. It's an extraordinarily high cost. And this is actually, we think, the barrier to adoption. The cost has to come down dramatically in order for this kind of reality to become true. Otherwise, it's just simply too expensive. And so it brings me back to what I said earlier about the performance difference between systems like GPUs and systems like Groq. Now, I'm not advocating that Groq was going to replace NVIDIA. I don't think it's going to happen at all. I think that these are very complementary. And I think there's many other companies building alternative architectures to GPUs. But no one has said that GPUs are the future of AI forever. And no, they were never built for inference. They're fantastic at training models. But something different is going to be required if we're going to actually bend the cost curve sufficiently to allow enough tokens to be generated at a low enough cost to impact all those sectors that I was just talking about. Now, you can see the cost per token there. I was talking about 4 trillion tokens a day. And you can see the cost per token on the NVIDIA and Groq systems. You can do the math. 4 trillion tokens a day times those numbers. Those are really, really big numbers. It's just totally impractical. It will never happen. We need to take these costs down by 100x more. And so that's what Groq is working on. We are trying to bend this cost curve and drive the cost as close to zero as possible so that we can start treating AI compute like electricity and making it as widely available as possible, as cheaply available as possible. Now, we think that if we were to achieve this, here are just some rough orders of magnitude difference. We think we can do this 12 times more economically. We can reduce the running costs by 75% versus what it takes to run these incredibly power-hungry, incredibly water-hungry GPU-based systems. We think we can take the total cost of ownership for companies in Malaysia who want to build this infrastructure and around Southeast Asia down by 10x. And we think we can do it at least 4 times as more energy efficient, which is really going to become one of the major bottlenecks in the AI infrastructure build-out, and already is. Now, look, these are directional numbers. This is what we think. This is where we think we're headed. I hope we can overshoot this and do better. And there's a lot of companies innovating, trying to figure out how to achieve this. And I think if we can do this in conjunction with every layer of the technology stack and all the different participants in the ecosystem, we can actually realize that future where, in Malaysia, for example, there are 4 trillion tokens being generated a day, and there's AI embedded in every aspect of everyone's life, in every industry, and we're better for it. We've done this before, very quickly. In Saudi Arabia, we're building the world's largest AI inference cluster. We delivered 20,000 chips there in Q4 last year, and now we're going to do 300,000. We just announced that we're doing this in Canada to build sovereign AI infrastructure for Canada in collaboration with Bell Canada, the largest telco. And we believe that building these in collaboration in a public-private partnership is the right way to think about AI infrastructure. So we have a unique approach to this that involves developers, government, private sector, and more. And so we're going to continue to pursue this, including here in Southeast Asia, and to build infrastructure. Okay, I'm out of time. We have a tagline at Groq. It's build fast. If you're an organization who is interested in AI, who wants to build fast, we certainly would love to talk to you. Thank you for your time. Appreciate it.
Thank you very much, Scott, for sharing with us your insights.